Good morning to all. This is in continuation of the previous one. Now just we are going to start the last concept of Unit 2. That is called linear time invariant systems responses to Fourier series. If we send a signal to a system, what kind of responses the system will provide to that particular signal? That concept just now we are going to discuss. This is the last topic. This will be the last topic of this unit. Let us start. Now, Fourier series response or responses to linear time invariant systems. In the first unit, we discussed a system is said to be a linear time invariant if it satisfies two conditions. One is linear time, another one is invariant time. These two concepts. So, no need to write again. Students should remember this. Linear time invariant system is linear time plus time invariant. Linear system and a time invariant system. That is called linear time invariant. Here, for example, look at under linear time invariant systems. Now we are going to discuss responses of Fourier series. How the system will respond when we send a Fourier series through that system. That is important one. Here generally it exhibits two properties. One is unit step response. Unit step response. Another one is unit impulse response. Unit impulse response. Unit impulse response. Before going to discuss this topic, students have to remember what is the unit step function. 0 for all values, its value equal to here up to this 0. The moment it becomes 0, the amplitude equal to 1, it continues like this. This is -1, -2, -3, 1, 2, 3, 4. This is called unit step function. We already discussed in the previous class. Now just look at here. The mathematical representation of unit step function equal to 0 when t is less than 0. The value equal to 1 when t is greater than or equal to 0. Very important. Just I am making you remembering all the previous important concepts again. Just as opposed to make it. Now here similarly we are going to discuss the unit impulse function. Unit impulse function is denoted by delta. Unit function is u of t. Another name of unit step function is called Dirac delta function. Now here just this is 0, this is 1, 2, 3, 4, -1, -2, -3 like that. Now here for all values of t less than 0, it is 0. The moment at t equal to 0, it rises abnormally up to which one? Infinity. When we integrate abnormally, when we integrate this one entire Dirac delta function, value equal to 1. After that, for all values it is 0. That means Dirac delta function has three conditions. The value equal to 0 when t is less than 0. At t equal to 0, its value equal to infinity. Its value equal to 0 when t equal to 0. Now just we are going to discuss the response of linear time invariant systems. When we send unit step function or unit impulse function through this system, what kind of response we will get? That is the purpose of discussing this topic. This is the last topic of the unit 2. Now we are going to discuss. Now, this is before discussing this topic, the fundamental points. Just again, I have given you the fundamental topics. So we are discussing this property with respect to these two conditions. That's why here I made a diagrammatic representation like this. So linear time invariant system responds to Fourier series with respect to unit step function with respect to unit impulse function. Here just look at unit step function is a continuous one from 0 onwards. 0 onwards, it gives the standard same constant graph, but here it ranges only at the single point, that is x equal to t equal to 0 only. That's the difference between. Now just look at now what is linear time invariant responses. Now just look at this is a system. What kind of system is this? This system is linear time invariant. This system is linear time invariant system. Now just we are going to give the response of this one. Response of this one. Now just look at. Let us consider a signal x of t. Now we are sending this signal into the system. This is input. We are sending a signal means what? We are sending a Fourier series of this signal. That means what? This Fourier series means what? Half a naught plus summation 1 to infinity an cos n omega naught t plus bn sin n omega naught t. We are sending this Fourier series. We are sending signal. Signal means what? Not directly signal. Signal is represented by a Fourier series. Now a Fourier series is being sent through a system. This is input. Now what we are going to get? We are going to get an output, that is y of t. What kind of output we get? That is important. Now just look at here. Here, what is the response of this system actually? Internally, the system has a frequency like that. A frequency wave of the system is, for example, h of t. What is this signal we are giving? X of t. Here, the moment it enters into the system, it is being mixed with the frequency of wave of that of the system. What are the system? Every system is having its own signal, that means wave frequency waves. It will be mingled with that system. Upon that one, these two will be combined with each other. The corresponding output is called the response of the system. For example, look at, we are sending x of t. What we got? Y of t. That means y of t output equal to what are the signal we already sent? X of t. This x of t is combined with a response of the system, that is called what? H of t. Combined. What are the signal we are sending? X of t. Signal means what? We are sending signal means you are sending the Fourier series of this signal. This Fourier series enters into the system. Now this entire Fourier series will be influenced by the response, the frequency wave of the system. The moment we sit in the bus, the moment the bus is going on the road, whenever there are speed breakers like that, what will get? Jig, jig, jig like this only. This type of vibrations will be from downwards to the upwards. That's why each and every passenger will be movement, the type of vibrations we got. Not only we get vibrations in our human bodies, but also seats, iron gates, windows, everything. That is the response of the system. At the time the system is called bus. The system can be a projector or AC, air conditioner, anything can be a system like that only. Every system will have the corresponding frequency of that system. That thing students have to understand. So the moment we are sending a signal x of t through a system, every system will have a corresponding or concerned wave frequencies. Now this signal will be combined with this one. Ultimately what we got is yt. Now just look at, suppose you sent a Fourier series this one. What output we got? Look at, half a naught plus summation 1 to infinity an cos n omega naught t plus Bn sine n omega naught t. Students have to observe very carefully. Is it a Fourier series? Is it not a Fourier series? This is also Fourier series. That means what? The nature of Fourier series never changed. But what could it change? It changed the values. Now just look at small a naught, uppercase a naught, small a n, uppercase a n, small b n, uppercase b n. Here, where, what is that, where, what is a naught? A naught equal to the corresponding previous a naught into system response a of t. What is a n? That is the previous corresponding a n into system response. What of b n? B n equal to here previous one b n with the system corresponding response. These three things students have to understand very properly. No differences. The physical structure of the Fourier series never changed. Only coefficients of the Fourier series is changed. You can make it. You can make that one only. Only coefficients of Fourier series is changed. Small a naught, a n, b n. There, uppercase a naught, a n, b n. But there is no change. Cos n omega naught t, cos n omega naught t. No change in sin n omega naught t, sin n omega naught t. All are same. Coefficient, everything is same. Only coefficients are changed. Why? What the reason of changing the coefficients? Because the Fourier series is being transformed into a particular linear time invariant system, that the previous coefficient is undergone with the present frequency of the system. Then a naught, small a naught is converted into uppercase a naught. What is a naught? Previous a naught into h of t. Look at all these h of t's are system responses, because a naught, a n, b n, all these are being transferred through the system. That is important. For example, look at, if you go for unit step function, if you send unit step function u of t through a system, through a linear time invariant system, what could be the output? What could be the output? Now, the output equal to y of t. Y of t is equal to unit response into h of t, where system response equal to h of t. But what is the value, maximum value of unit step function? 1. 1 means what? 1 into h of t. So what you are going to get equal to the same system's frequency wave you are going to get. Understanding? For example, if you send unit impulse function, that means what? Delta of t. If delta of t you send through a linear time invariant system, now what output you get? You get the output. The output equal what? Y of t. That means what? Y of t is equal to delta of t into the system frequency h of t. You can get multiplication. For example, here if you write y of t is equal to u of t star h of t, this is, the star represents what? Convolution. This is called convolution. Convolution means what? Combining two frequencies and producing a new signal. That is called convolution. Here just look at what is the, here if we apply the concept of what is the convolution regarding this LTI system, this convolution is equal to y of t is equal to delta of t star h of t. Whenever you are rising using delta of t, at a particular point the system provides maximum response, only on particular point, not throughout the system. At a particular point only it gives the maximum response of the frequency. So these are convolution. Whenever you are using star, the star is for convolution. The concept of convolution is always to produce a new signal by combining two existing signals. This is convolution. So these are all the responses: linear time response, unit impulse function response, when these two kinds of signals are being passed through linear time invariant systems. So this is the very important for you. Generally they will ask you for 3 marks or 4 marks for this one. Students have to concentrate on the relations of this one. So there is no change in the Fourier series, only change in the coefficients only, change in the coefficient. How the coefficients could change, undergone the changing, like this only. Look at, there is a difference, small a naught, uppercase, small case, uppercase. This is the representation regarding the convolution concept of unit step function 2. There is the convolution concept of the unit impulse function 2. Students have to make the differentiation between these two concepts at the same time. So thank you very much. This ends unit 2, end of the unit 2. In the next session we are going to start unit 3. Thank you.